So we're going to take a look at 2017 Maths Higher Level Paper 2, question 2. And we have an experiment that measures fuel consumption at various speeds for a particular model of a car. The data collected are shown in table 1 below. So we have to find the correlation coefficient, and the easiest way to do it would be to go to the stats mode on your calculator, enter the table data, and then find the value of the correlation coefficient from the statistics parameter on your calculator as well. In any case, the value of this correlation coefficient is equal to minus 0.9565. So corrected to the 3 decimal places, we round up, so that will be minus 0.957. And then we have to plot the points from the table and draw the line of the best fit. So for 40, 21, thereabouts, 48, 16, thereabouts, 56, 18, somewhere over here, 64, 16, a little bit less. For 72, there is no point, but for 88, we have 13, which is well below 10, somewhere over here. For 96, then a value is equal to 11, right above 10, and for 112 it's 9, so it has to be below 10, not somewhat. So if you draw line of best fit for this particular graph using ruler, make sure you use a ruler. This graph will be going downwards, and make sure that you have a similar amount of points above and below the line. And the slope of the best fit line is found to be minus 0.5. So what does this value present in the context of the data? The way I would explain this is as follows. As the speed increases, the fuel consumption in kilometers per liter decreases. So less fuel, So the slope of the line of best fit is found to be minus 0.15. What does this value present in the context of the data? So what it says is that fuel consumption explained in terms of kilometers per liter is going down, which then tells me that lower number of kilometers is traveled per liter of the fuel as the speed increases. So then continuing with this question, we're talking about Mary, who drove from Cork to Dublin at an average speed of 96 km per hour. Jane drove the same journey at an average speed of 112 km per hour. Each traveled 260 kilometers and paid 132.9 cents per liter of the fuel. Both used the model of a car used to generate data in table 1. So we have to find how much longer it took for Mary to complete the journey. So a couple of ways of doing it, but I suppose the easiest way to do it would be to remember that if speed is equal to distance over time, then time it will be equal to distance over speed. So here the same distance, so person who travels faster will cover the distance in a shorter period of time. So then we have to say that difference in time will be equal to the longer time minus the shorter time. So that will be equal to 260 divided by 96 minus 260 divided by 112. So that gives us 24 minutes. 24 minutes. It will be a fraction of an hour turning into minutes at 24 minutes. So then based on the data in table 1 and our average speeds, we have to find how much more Jane spent on fuel during the course of this journey. So Jane is traveling at 112 kilometers per hour and Mary is traveling at 96. So based on this table, Jane is traveling 9 kilometers to each liter of the fuel she burns, and Mary is traveling 11 kilometers to each liter of the fuel she uses. So Mary will be is traveling at 96, so she travels 9 kilometers. Sorry, she travels 11 kilometers per liter. And then Jane